Hi everyone, let's solve this problem, task scheduler. You are given an array of CPU tasks, each labeled with a letter from A to Z and a number n. Each CPU interval can be ideal or allow the completion of one task. Task can be completed in any order, but there is a constraint. There has to be a gap of at least n intervals between two tasks with the same label. So what they are saying is, let's take this example. So there are task name like labeled from capital A to capital Z, and each task needs to have gap of 2. So in this case A should have gap of 2 because n is 2 in this case, and then in between I can pick up any other task, right? And again when I pick up B, I cannot pick up B again immediately. I need 2 units of time between, so I will pick up B here. Again I will have a ideal time here because between A and next A it should be a 2 units of time, and then again I'll pick B. In this case the total unit of time needed is 8. So let's take the other example. So in this case what we are doing is we can pick up A, and next A can be picked up between, there is 1 unit of ideal time, right? So A, and then I can have C here, and then B here again, and then D again, then B again. So if you see between A and A there is 1 unit of ideal time, and between both B's there is a unit of ideal time because n is equal to 1 here. So let's take one more example. In this case A task occurs thrice, B task occurs twice, C task occurs twice. So let's say I take any one of them, B or C. Let's take B, then I pick up A, then I can pick up C, then again I can pick up B, then again A, then again C. So in this case if you see both B and C tasks are done, but the A is left. So but I cannot pick up A immediately because I need to have 2 units of ideal time. So I'll pick up A after this. If you count all of them, 3, 6, 7, 8, total units of time is 8. Can we do it better? Yes. Let's pick up A first, then B, then C, then A, then B, then C, then A. In this case we have kind of finished this entire task in 7 units of time, and we cannot do better than this because every task will take at least 1 unit of time, and there are 7 tasks in this, and the units of time is 7, right? Why were we able to achieve this in shorter time than the previous one is because we kind of picked the most frequently occurring task before, so that we have enough units of time in between, right? That is possible in this case. So can it happen that, let's say for example we just have all A tasks, in this case we will just take, no matter what we do we will have to wait for 2 units of time in between A. The reason being why we need to take A or the most frequently occurring task at the first is because if there are any tasks which are occurring less frequently, they can be fixated in between so that all A's can be accommodated and all the least frequently occurring tasks can be ensured that they are between. That is the reason why we are going to do this. So in order to get the most frequent elements, we are going to use a max heap. So let me just take this particular example itself. Let me explain how the max heap is going to help us. So as I discussed already, A is 3, B is 2, C is 2, and in the question itself they have mentioned that we can process the task in any order as long as we are maintaining the n units of time between the similar tasks, right? So I will just insert the task counts, right? I just need to process this. So initially the time will be 0. I'll increment the time at unit 1 time. I'll get the maximum frequent element from this, nothing but 3. I will process 1 unit of it, and remaining unit is 2. Then I will maintain a queue. In this queue, I am going to maintain remaining units of task. And when can I pick up? 1 plus 2. At 3 time unit, I can pick this up. Then I'm done with this. And I'll check if there is any task which can be picked up from the queue at time unit 1. No. Then I'll pick up the maximum element from the heap. It is 2. I'll process one of them, and the remaining task is 1. And also before that I'll have to increment the time 1. And now 2 plus 2 will be 4. So I'll be adding here. And this is also done now. Now I'll check at 2 units. Do I have any task at the queue? No. So I will again get the max from the heap. 2 minus 1 will be 1 again, and this will be 3 units. 3 plus 2 will be 5, right? 1 comma 5 will be. So there is 1 unit of task which can be picked up at 5 or more than 5. So again, now at 3 units of time I have in the queue, I know that there is one task which can be picked up which has 2 units of work. I have pushed into the heap, and then I am moving it to the next iteration. So again I get the maximum of the heap. I got 2. 2 minus 1 will be 1. So now 1 comma 4 plus 2 will be 6. So this has already been processed, so I can pop it out. Already it has been popped up, and then this also has been popped up, right? And then now at 4 units I can pick this up. So I will insert 1 unit of work into this, and I'll move to the next iteration. Now from the heap again I'll get the maximum. Maximum in the heap currently is just 1 element, so I'll get it. 1 minus 1 will be 0. There is no unit of task remaining, so I can just kind of ignore it and then move to the next. Like at the queue, I also need to check if at unit 5 if there is any task. There is a task, so I'll insert into it, and I'll move to the next iteration. When I move to the next iteration, I kind of get 1. 1 minus 1 will be 0 again, so I don't really have to process it. And then at 6, do I have anything? Yes. So I'll insert 6 into this and then increment my time. And at this I just have 1, and 1 minus 1 will be 0. I don't really have to insert into the queue. All of these elements are also processed, and all the elements in the heap is also processed, so we don't really have to do anything in this. The entire task is done, so the total time is 7. We just return it from this function. So now we are going to write the code for the same. So we have just A to Z, that means there will be 26 characters only. So we are going to define an array of 26 and then fill them up with zeros. And then I will iterate over task of task, and then I'm going to count array of task will be task.char coded minus coded plus plus. So what I'm trying to do here is, so basically let's say we have array, these are indices, I'm mapping A, B, C, so on all the letters, and we are going to, inside the array we are going to store the frequency of the elements, right? We know the frequency of this element, so we are going to get the frequencies. Now I'm also going to define max heap, max priority heap queue, and then I'm going to iterate over all the counts. So there are 26 elements, so I'll iterate over this, and max heap dot enqueue, I will just enqueue count array of I. So basically I'm inserting all the frequencies here. Now I'll also define the time and also a queue. While max heap dot size is greater than 0 or queue dot size is greater than 0, if any elements are there in either of them, first we are going to increment our time, and then if max heap dot size is greater than 0, in this case what we are going to do is we kind of like get the max frequency from the heap, and then we decrement one of them because we are processing one unit. We will decrement it and we'll check if the max frequency is not equal to 0, only then insert into the queue dot push. What are we going to insert? We are going to insert the max frequency remaining, comma max frequency remaining, because if you, okay, let me also write remaining so that it's not confusing. Max frequency remaining plus time plus n, which is nothing but the interval. And then if there are any elements in the queue, we are going to check if the element on top of the queue and its time is equal to our current time, then we will process that element. How are we going to do that? First element, let's say, and we are going to get queue dot pop. Once we get that element, we are going to also insert max heap dot enqueue element of 0. Right, we are going to store, what were we storing? 2, 3, number of units of work and also the time, right? Time we don't need it, but we need to store into the heap the units of time, the units of work remaining. So we are going to do elements of 0, right? Then we are going to just return the time. So let's see by running this. Okay, let's see why we are getting the why. Okay, one more thing is that if count array of I is greater than 0, only then insert into the heap. Otherwise we don't really have to, because let's say for example in this case there is no C task, why will we insert into the heap, right? We should not. So let's run this, right? Let's submit it. Yes, we have successfully be able to submit it. Now let's understand the time and space complexity of this solution. Time complexity is, so we are kind of iterating over all the tasks, considering there are n tasks. Then we are iterating 26 times because the size is 26 characters only, and then we are having a max heap and also the queue. So if you kind of take this entire part, at any given point of time max heap or queue will have at max 26, because unique tasks, if you consider all the tasks, a equal to 100, b equal to 200, so on, also all the tasks will be inside the heap will be only their counts, right? So if you check in this example, there were only these 3 elements, right? And the number of elements in the heap were just 3, count was 3, right? The same thing will happen for all, if all the characters are there from A to Z also, and A to Z there are only 26 characters, so there will be only 26 iterations that will happen, and it can happen multiple times, but it will happen only 26 times. It is not going to increase with the input which we have, so it is 26 and 26 for the heap and queue. And the space complexity would be big O of 26 for the count array, and then for the heap again there will be 26, and then again 26. And generally for getting the element from the heap and deleting the element from the heap takes log n time, but here it is going to take log of 26 because there are only 26 elements in the heap at max. So log of 26 will always be constant, and we can ignore this, right? Let's say for example log of 32 will be 5, right? So 5 is a constant, like we are comparing 26 to 32, but yeah, it will be less than 5, right? So we can ignore that. So the overall space complexity will also be 26 or big O of 1. I hope the solution is clear. Thank you.